In this video, I am going to go over the distributive property, which is the final property of numbers that we'll be learning about this week. And I want to start off by saying that this distributive property stuff is confusing. I think I said a couple weeks ago that in this section that we're in, the object isn't going to be finding the answer. The object is going to be kind of the process. So this is going to feel really weird at first. So be patient with me. Make sure you watch the whole video. And if at any point you're asking yourself what the point of all of this is, that is a valid question. And hopefully I'll circle back to that at the end. So I just want to start off with this activity right here. And I'm also noticing that I accidentally labeled all of these number 1. So go ahead and just change this to number 2 and number 3. My bad. So there's this mathematical concept we can use to do this. Basically, you can use parentheses to multiply a group of terms by a single number. So I'm using combo meals to illustrate this, and these are just really weird combo meals, so I'm sorry, I don't know what I don't know what restaurant you would find combo meals like this, but you never know. Maybe you just have a hankering for 3 hamburgers and 1 drink. You never know. Anyway, so let's say you want to order 4 of combo meal number 1, and the object here is to figure out how many of each thing you're going to end up with. So within 1 combo meal 1, there's 1 hamburger, 1 drink, and 2 french fries. So I'm going to use variables to represent that here in number 1. So there's a hamburger. There's a hamburger, a drink, and then I'm going to say, and then there's 2 french fries. And I'm going to indicate that with a little 2F, just to indicate that there's 2 french fries there. So that's an expression for how many items are in combo meal 1. Now, if I want to order 4 of those, how many of each thing am I going to end up with? Basically, what we end up doing is multiplying everything times 4. So there's 2 ways I can do that. I can write out 4 times each of these things, 4 times h, plus 4 times drinks, the number of drinks, plus 4 times 2 french fries, which would end up being 8 french fries. So I can do it all that way, or I could just draw parentheses around this whole thing and just put a 4 out here. So basically, these 2 expressions represent the same thing. 4 times this, 4 times this, 4 times this looks like this as well. Okay, I know. A little confusing. Be patient with me. You ordered 2 combo meal number 2. So go ahead and write out an expression for combo meal 2. So in combo meal 2, there's a hamburger. 1 hamburger, there's 4 french fries, and 2 drinks. Okay. So if I want to order 2 of combo meal number 2, I'm basically multiplying everything times 2. I'm going 2 times the number of hamburgers, 2 times the 4 french fries, and 2 times the 2 drinks. And what I end up with is 2 hamburgers and 8 french fries and 4 drinks. Pause the video real quick, see if you can do number 3, and then hit play. Okay, so number 3, I have 3 hamburgers, 2 french fries, and a drink. Again, I have no idea what kind of combo meal this is. This is a really weird combo meal. But whatever. So I want and I want 5 of it. It's the weirdest combo meal ever, and I'm ordering 5 of it. That's fine. So anyway, 5 of that combo meal, I'm gonna end up with 15 hamburgers. Remember, if there's 3 hamburgers and just 1 of the combo meals and order 5 of them, that's 15 total hamburgers. That's 10 total orders of French fries and 5 drinks. Ready for a party, I guess. So the next thing is is actually a strategy for finding the area. So 3 friends agree to paint parts of a background for a play, write an expression for the area of each part, then write an expression for the area of the whole background. So the idea is that there's 2 ways to find the area of all 3 of these pieces. I could find the area of each piece individually and add them up, which would look like this. Keep in mind, we have a variable here for the height, so we can't actually find the total area, but we can write expressions that would represent the area. So again, we can't find the answer, but we can show our work. The area of each piece. So the area of this piece, remember the area of not a triangle, the area of a rectangle is base times height. So I guess I'll do 5h. Just a side note, remember, whenever you see a number in a letter shoved up together like that, and there's no operation, it's that invisible multiplication. So what you're looking at is actually 5 times h. So the area of each piece, right? There's the area of that piece. The area of this piece would be 8 times h, and the area of this piece would be 4 times h. And I would add all of those together. And that would give me the total area of the whole thing. So the other way that I could do this is, if you can imagine, if I shoved all of these pieces together, I don't have a very good way of drawing that for you on here, but if you can imagine I just shoved them all together, I would have one big giant rectangle with a base of 5 plus 8 plus 4, and the height of the whole thing would be h. So the other way I could write this would just be the height times 5 plus 8 plus 4. That's the distributive property. It's this idea that instead of going 5 times h plus 8 times h plus 4 times h, I can just go h times 5 plus 8 plus 4. The next thing we're going to do is we're going to try this out with some actual numbers and not variables, so you guys can see what I'm talking about. So the distributive property allows us to get rid of parentheses by bringing multiplication operation to the inside of the parentheses. What the heck does that mean? So basically, there are these, it's a way of writing an equivalent expression. So in number 1, I've got 2 times 3 plus 1. And again, whenever you see a number shoved up against a letter, or in this case a parentheses, there's invisible multiplication hiding in there. So in number 1, I'm going 2 times 3 plus 1 equals. And I know you're probably all tempted to go like 3 plus 1 is 4 times 2 is 8, and my answer is 8. But unfortunately, that's not what we're doing. That would be a lot less confusing and a lot easier, but unfortunately, that's not the point here. What we're doing is I'm going to rewrite this expression without the parentheses. So I'm going to distribute this 2 to both of these numbers inside the parentheses. That's where the word distributive property comes from, or the distributive, at least that's where I think it comes from. Anyway, so what I mean by that is I'm going to distribute the 2 to both of these numbers in the parentheses. So what I'm going to end up with is 2 times 3 plus 2 times 1. Instead of doing the addition first, I'm doing the multiplication first, which I know you're not allowed to do, but the distributive property says that you can. So the result of this is going to be 2 times 3 is 6 plus 2 times 1 is 2. So that would be your final answer here. And again, like I said at the beginning, be patient with me. What is the point of this? All of that will hopefully become clear at the end of this video. I'm going to go ahead and do number 3. So in number 3, we can go, the other thing we need to do is we can also go backwards. Instead of distributing a number inside of parentheses, we can take an expression without parentheses and undistribute a number from both of those numbers. So what number can I undistribute? My final product is going to look something like this. What I need is I need a number that goes into both 10 and 12. And again, this is math you guys know how to do. If I asked you guys to simplify 10/12ths, I guarantee almost all of you would be able to do that, right? How do I hate filming these because no one can answer my questions, so I'll answer them. I can simplify this by 2, right? So because I can simplify that by 2, I should be able to undistribute a 2 out of this expression. And if I do that, what's going to be left over inside? If I divide away a 2 from 10, I'm left with 5. And if I divide away a 2 from 12, I'm left with 6. I'll know I've done this correctly because if you can imagine going back the other way, you should end up where you started. So pause the video, see if you can do number 2 and number 4, and then I'll do those with you. So number 2 has subtraction. That doesn't really change what you're doing here. Again, you're just taking 3 and multiplying that 3 times both numbers in the parentheses. So you're going to end up with 3 times 4 minus 3 times 3. 3 times 4 is 12, minus 3 times 3 is 9. Going backwards, I've got 18 plus 15. I need a number that I can undistribute. Is that a word? I'm making it a word. I need a number that I can undistribute from the 18 and the 15. You gotta think of a number that goes into both 18 and 15. The only thing I can think of is 3. So if I undistribute a 3 from the 18 and 15, what's gonna be left over in the middle? If I want this first number to be an 18, I'm gonna have a 6 left over there. And if I want this to be 15, there's going to be a 5 left over here. And again, one way you can confirm that you did this correctly is if you go backwards, you should end up with where you started. It works the same way over here. The other way you know you've done this correctly is if you actually do this math, you should get the same answer. 18 plus 15 should be the same thing as 3 times 6 plus 5. That's another way you can verify that you did this correctly. All right, guys, some more examples of the distributive property. We are on page 16 now, are these area models. Again, if I wanted to find the area of these shapes, if I wanted to find the area of this whole thing, there's 2 ways I could do it. I could find the area of it in 2 separate pieces, or I could find the area of the whole thing. And so what I mean by that is I could just go, I could just find the area of each piece. I could go 3 times 5 plus 3 times 7. That would give me the area of both of those combined. Or I could just go 3 times 5 plus 7 combined. Over here, just an example with subtraction. If I just wanted the area of this darker shaded region, there's 2 ways I could do it. I could find the area of this whole thing, which is 4 times 7, and subtract the smaller area, which is 4 times 2. Or I could just find the area of 4 times and the 7 minus 2 part here. So just some more examples of the distributive property. In number 1 through 8, you are going to use the distributive property to rewrite these expressions, and then down at the bottom you are going to match the equivalent expressions with those boxes. So try it on your own. I'm going to start doing it right now. You can pause the video, you can work with me, or you can just fast forward to the end to check your answers. And then I'll kind of narrate through some of these as I do them, just so you can get more insight here. So again, the whole purpose of this is if I have an expression like this, I'm using the distributive property to rewrite each expression. So if I'm starting with something without parentheses, I need to figure out how I can create something with parentheses in here. So first of all, this number needs to go into both 15 and 35. So I'm thinking of 5. So if I undistribute a 5, again, you can kind of visualize this happening, right? If I undistribute a 5 from both 15 and 35, I would need to put a 3 here and a 7 right here. I would end up, and if I went backwards, I would get 5 times 3, which is 15, and 5 times 7, which is 35. If I'm starting with an expression with parentheses, that means that I'm going to need to take this number out here and distribute it into the parentheses. And so this way is almost a little bit easier, right? Because all I have to do is just do the multiplication. So 2 times 5 is 10, plus 2 times 8 is 16. Works the same way with subtraction. If I'm starting with parentheses, I'm just distributing this, doing that multiplication. This is 36 and minus 20. Oh, we already did this one on the other page, but that's fine. We'll do it again. 2 and 5 and 6. So, remember how I said that there was a point to this. And if you look at 5, 6, 7, and 8, we now see variables. So this is where the distributive property really is useful, and where you'll use it when you reach 7th and 8th grade into higher levels of algebra, is because if I'm solving an equation with this expression in it, there's nothing I can do here. Like, I can't go 3 times x, I can't go 3x plus 10. I can't do any of this math because there's a variable right here. As long as I don't know what this number is, there's absolutely nothing I can do here. The only thing I can do is I can use the distributive property to at least undo or get rid of these parentheses. That's going to be a huge a very helpful thing when we get into higher level algebra here. So just because there's a variable there, that's fine. Do all of the multiplication that you can. So 5 times 3x. I can't do anything with the x, but I can do 5 times 3, which is just 15. And 5 times 10 is 50. So without getting into much depth as to why that's useful and how you're going to use that and why it's important, that's what we use the distributive property for, is because if I have an expression like this with variables in it, I can't do any of this math anyway. The only thing I can do is I can move these numbers around using the distributive property. Here's where it gets a little bit tricky. What can I undistribute from this expression? I'm looking for a number that I can put out here. I'm looking for a number that goes into both 2x and 4y. So when you've got variables here, you can still use the strategies that I was explaining to you before. So I'll just tell you here, if I factor out a 2, if I undistribute a 2, here I'm going to be left with just an x, and here I'm going to be left with a 2y. And I know that because if I go backwards, right, I'm going to end up with 2 times x, which is 2x, and 2 times 2y, which is 4y. Okay? So when there are variables in these expressions, don't worry about the variables. Just do the math that you can and leave the variables where they are, I guess. And again, when you're starting with parentheses, you're doing multiplication to get rid of them. 6 times x, I can't really do 6 times x, so I'm just going to leave it as 6x. And 6 times 7, I can do 6 times 7, that's 42. When you're starting without parentheses, you're thinking, what number can I divide out of both of these numbers to the outside so I can create these parentheses? Let's see, the biggest number that goes into both 10 and 12 is 2. And there's an x there, so I'm going to put a 2 here. And 2 times 5 is 10. Then I'll put the x back in there. 2 times 5x is 10x. And then 2 times 6 is 12. All right, last thing we need to do is we need to match the equivalent expressions. Let's see. So again, I think what I'm going to do here is just distribute that 9. Again, when there's variables, that's fine. Just do the math that you can. I can do 9 times 2, which is 18x, and I can do 9 times 3, which is 27y. Remember, these variables just stand for numbers that we don't know. What I have here is 18 times x plus 27 times y. Without knowing what those numbers are, that's all of the math that I can do there. And is that one of my choices? Yes. Great. Let's see. So I'll just go through these. Again, I really encourage you to pause the video at this point and work on your own. You can always unpause or fast forward. Let's see. Well, I could either undistribute the 5 or I could undistribute the x, but it looks like this is the one that matches, so we'll do that. X 5 plus 5 plus 5. And then this is a great way to check to make sure I'm doing this right, because if one of them isn't one of the options, then I know I've done something wrong. Let's see, 5, 2x, 5y. I just realized my hand has probably been blocking most of this. I apologize. Let's see, 3. Wait, no. Well, that's actually a good point. So one thing to keep in mind is that would be 9y minus 6, right? So there's nothing wrong with what I just did there. This would give me 27y, this would give me 18. That's totally fine. But you'll notice that it's not any of the available answer choices. And the reason is because there's actually another possible right answer to this. Because 3 isn't the biggest number that goes into both 27 and 18. Usually, when you're using the distributive property, you want to try to pull out the biggest number that you can, the greatest common factor, if you will. So if you feel like you did something right, but like you're getting it wrong, or it's not one of your possible answers, think about that. Maybe there's a bigger number that you can factor out. All right, that is the distributive property. Hopefully that was helpful to you. If you have questions, make sure you watch the Khan Academy video for another demonstration explanation of it, and make sure that you come to my Zoom office hours this week. Zoom is totally optional, but if you have questions, that's a good time to ask. All right, hope you're having a good week.